Okay, simple Ruby DSL techniques. Let's focus on that. Ruby is in bold. So apologies if this talk will bore you, because it's actually a pure Ruby talk. I won't be referencing C, won't be comparing to Java or Clojure, and there'll also be no references to architecture. Okay, that said, I myself am a polyglot programmer, but still ended up spending a lot of time with Ruby projects. Ruby is not my favorite language. If you want to know my favorite language, ask me offline. Yeah. That said, I still like Ruby a lot. It's helped me think differently. Okay, let's get started. So when I registered and my talk got selected, the organizers, who are doing a wonderful job, by the way, reached out to me and gave me a set of guidelines for speakers. And it said one of the guidelines was start with a joke, or at least end with a joke. So here's my obligatory humor just to get things started. But there's another star disclaimer. Jokes can offend people, because the most funny jokes are usually the ones which are offensive to someone. So this joke may also be a little offensive to some communities, but the offense is not intended. It's accidental. And you may get a hint of satire in it. It's also not an original joke. You may have heard it multiple times. So please still make an effort to laugh at the end of it. It'll just make me feel good. Okay, so here's the joke. Okay? What is common between beggars and developers? Don't answer. I know you know the answer. It's a very poor joke which has been going around for a long time. It's a very old joke, yes. Ajay will know. He's old. Older than Chad, maybe. Well, I'll tell you the answer, okay? So, am I moving too much? Sorry, I'll just pause here. Okay, so when two beggars meet at a railway station, that's not the common part, okay? So beggars are meeting at a railway station, or when two developers meet at a tech conference. They introduce themselves with the question, what platform do you work on? Thanks, and some laughter also I heard. I really appreciate it. There's a slight satire in it too, though, that you can have philosophical thoughts about later. There's a difference between beggars and developers also, though. Developers continue their conversation with another question, what domain do you work on? This is very, very typical. In fact, this is a good opportunity to get some more examples of domains. What domain are you working on? What project is your domain for right now? Just shout out the answers. Could be finance, could be retail, could be anything else. Social? Entertainment? Education? Sorry? Health, yeah, health. Okay, good. Warehousing as a domain. Okay, interesting. Logistics, good. No one mentioned these. Maybe because we think of them as implementation concerns, right? They don't really solve any, they're not very relevant to any business domain that we work in. These are still very relevant, we know all of it, but they are implementation concerns. I still like to think of them as a domain though, perhaps as a technical domain. Maybe you will also ascribe these things to perhaps a technical domain. But what are these things? Technical domain, business domain, what is the domain? There are obviously answers out there. I'll share my perspective of it. For me, a domain is about a specialized field, right? It is about common context, which is shared by those specialists, people who work in that specialized field. And it's about common vocabulary used by those specialists to communicate with each other. This talk is kind of focused on the last point, which is common vocabulary among specialists. And here are some examples to make it clear what I'm talking about. How many here think that their grandmother, there's a grandmother test, again I may be offensive to a few people, but your grandmothers will understand what these sentences are? No one's raising their hand. How many of you guys understand these sentences? Others are being shy because I was hoping for a full house here. Okay, so yes, a few hands did rise, right? We clearly know what these things mean. And Ruby also understands these terms, right? We do not need to explain to anyone what a private method is. We do not need to explain to someone what delegation is. And Ruby kind of represents these words as is. So this is actually a DSL in core Ruby. So I'm sure you guys must have used these methods before, actually. They're Ruby methods. But when you talk about DSL, these do not necessarily come out as clear examples. More commonly, examples include our favorite active record, been mentioned multiple times today. That is a DSL. Our controllers in Rails, they have these DSLs. And libraries as well. One of my favorite libraries is Sunspot, because they make working with Solr so easy. I remember on a Java project, I was working with Lucene in Java, and I don't want to go back to it ever again. That was difficult. And all these examples are Ruby DSLs for the technical domain, right? So the question is, where are the DSLs for the business domains we were all mentioning out here in the room? We mentioned health, education, retail, finance, logistics, right? Where are the DSLs for those domains? Well, framework writers don't write them. The reason they don't write them is they cannot guess what you need as consumers of those frameworks, right? They can guess that any domain will need some sort of authentication. Caching will be important. You need to persist all the data that you are dealing with. They can guess about those things. They cannot guess what your business problem is. That's what your clients know. So who has to write those DSLs? Obviously, it can't be those framework writers. It has to be you for your business domain. And why write them? A simple answer could be, why not? But if we have good experiences working with Rails all these years, we have experiences working with Active Record and loving it. And what we love about them is how clean they look, how easy they make things to implement. Most of it is because of what I cited as DSL examples. So there are definitely productivity gains there. Why don't we want to harness those gains for our business domain as well? Okay, so that ends part one of my talk, which was about fluff. Now I'll focus more on the stuff bit. I like a balance of fluff and stuff. Some people are more about no fluff, just stuff. So if we were to write a DSL, what is the first step? First, you need to understand what DSLs are about, right? And that understanding comes from recognizing the DSL. Just like refactoring. Refactoring is a good thing, but you can't really do refactoring unless you first recognize code smells. And then you relate them to what refactoring techniques and help you remove those code smells. So this is my attempt at trying to classify DSLs so that you can recognize them a little better. I'll repeat the same examples. Look at them carefully. This sort of DSL I would like to classify as a fluent interface. It's not a term coined by me. I think Martin Fowler blogged about it many years back. He's recently written a DSL book as well, where he relates fluent interface to implementing DSLs. We'll take another look at this sort of DSL. And this I like to call single line declaration. I mean, nothing very unintuitive about it. It is a single line of Ruby, right? And it is a declaration. I want to spend some time talking about declaration width, though. I think a lot of DSLs are declarative in nature and not imperative. I hope you understand these concepts. If not, go and read about it. It'll help you figure out ways of looking at code. SQL is a good example of a declarative language. You say select star from this table. You don't tell the database how to go and fetch the records from the database, right? Just like this guy. So around action, wrap and transaction, only update. So you're telling Rails that for the update action method, just call this method before and after, right? So it's a declaration, not necessarily exposing the implementation. Moving on though, you can also declare stuff using blocks. So not just single lines, you can split them into multiple lines by passing in a block. So block declaration. And these are the three simple categories that you can actually classify most DSLs into. Most of the DSLs that you'll encounter in code, you can use these three classifications. Now I'm talking about implementing them yourself, so which takes us to the next stage. You need to recognize the secret sauce, the ingredients which can help you implement such DSLs. So let's take a look at Fluent interface. What you'll need is basically just method chaining and possibly the builder pattern, or a variation of the builder pattern. I'll get into more detail later maybe. For single line declarations, what you'll need is class methods. These are typically class methods. And some bit of metaprogramming behind them. Typically, the metaprogramming will be very basic in nature, nothing that you guys can't handle. And moving on to block declaration, it can be class methods like this one, or instance methods like this one, and again, metaprogramming behind it. This can sometimes become tricky and can go into what some may think is advanced metaprogramming. But again, not something that we can't handle. So let's look at some examples. I'll be sharing some inspirations, basically code which emulates the kind of concepts we've dealt with in real client projects. And I have put this up, some of the examples on GitHub as well, so you can take a closer look later. So we'll tackle Fluent interface first. That's the DSL we'll be implementing. The domain is production support, a ticketing system maybe. You're definitely dealing with incidents, right? And let's read it out. Incident report for app, severity critical major, priority high medium, from this date to that date, retrieve incidents. Maybe something that a business user may understand. It's still a possibility because these symbols may confuse them, the colons and the dots, but still something that a business person may understand. What is important is that, again, from an implementation perspective, you guys can probably guess that there's nothing special in it. And you should be asking right now, okay, what's so special about it? What makes it a DSL, right? Active record, if incident report is an active record, you can simply use where and just do these things in one line. Why do you need so many dots in between? Correct? The question is the API. What makes it different is that the API embraces the domain. The API represents the domain, concept from the domain. It's not a generic persistence-related domain that you're trying to implement with a where, right? So let's take a look at what's happening behind the scene. Is this readable? People in the back? No? Okay, so what I'll do is probably switch this out. This can always be risky, but let's see if this works. Yeah, I'm still on TextMate. Not Sublime, not Emacs. Sometimes Vim. Okay, we were looking at an example of Fluent interface. Okay, what I can do here. Whoops, too big. Better? People at the back, no? Yeah? Okay. Cool. So ignore this. Let's just assume there is a class called incident, which wraps the data you're interested in. This is the interesting piece. This was the class which was featuring in the DSL. We have a simple class method. Look at it. Does nothing interesting. It delegates to another class level method called new, which we know does what? Invokes the instance method called initialize, right? So basically, we start off with a list of systems in the class which we capture in an instance variable. And then there are a series of methods which are very similar in nature. You take an argument, store it in an instance variable, and this bit is important. It returns the object itself. So this facilitates your method chaining, because you can do incident report dot for, which will eventually just return you an incident report object. You do a dot on it, say severity, that will return you the incident report object again. Now you can do a dot priority, and so on and so forth. Straightforward, yes? You guys following me, right? Okay. So nothing special there. Somewhat related to a simplified version of builder pattern. And then this piece is interesting. Once you've collected all the options that you want, you now want to use those options to do something interesting, something useful. So you'll probably have a method call in the end which does the heavyweight lifting. For example, in active record, which actually just implements active relation, right? What is the method which finally takes all your where arguments and does something about it, makes a database query? No? So you can do a dot active record class name dot where dot join dot order dot limit. What finally fires that query? 2A, yes, it is 2A. Even when you do an each and stuff like that, internally 2A is the one which makes a database query. Also, my reference may be a little dated. This may not be necessarily the case in the latest version. So this is like an equivalent of that. It takes all of your information and then finally does something with it. As you saw, this is the project which I've checked in on GitHub. It doesn't really have active record as a gem dependency, nor do I have tables. So I'm just simulating that there's something which will give you all the data that you need, but too much data, and you have to do filtering after. So that's just my simple implementation here. It could actually be incident if it was an active record. It could actually be incident.where, and then the where is generated based on all the options you have taken from your client code. Right? Now let's get to the next interesting piece, that how do you use the data that you've captured from your DSL. Always make a reasonable judgment calls about default data. Right? For example, here we are saying that nil is actually a valid default, because there is always a chance that someone will not call this method at all. Right? So just make sure that your builder methods, don't make an assumption that everyone will call those builder methods for each and every data attribute that you have. And then you finally use it for your filtering and stuff like that. And then you return the result, which is in the end the select. Any questions about this so far? Nope? All clear, right? Okay, I'll move back to the presentation. Okay. So some more examples. That was a simple one. These are again slightly tweaked versions from actual code bases. That's where we, had something similar where there were worker jobs in production that would work in the background, but they could end up with errors. So this is a combination of active record plus the builder pattern DSL, where this object returns you a new object, and then you have these methods on it. On another project, we were using Neo4j, a graph database, and we wanted to generate cipher queries, which are basically strings that you send across in a RESTful API. But to generate that string, we again had a DSL around it. Yeah. Coming to single line declarations, another example, maybe from a community forum. You have posts, which have attributes like title, description, and author. But people are bad. So sometimes they use swear words in their comments. So we would like to sanitize profanity in title and description. And that's all that you write in your class declaration, right? And then this is how it will be used. So you can create a post with a swear word, but when you actually get back the value, it will be asterisked. But for some purposes, you still want the original value, so it's not like it's lost. So you have this method, title without sanitization, which returns you the original value. We know that struct will give you this method title, but it's not doing the same thing that the struct implementation title will do. And we see this new method, which has suddenly come up from somewhere. It's not there in the class definition. Clearly, there is metaprogramming involved, and this is what it looks like. Hopefully, this is clear enough. Basically, there's a module which we've just included, right? And then there's a class method there. So that's our class method. And then we just do our thing there. We have to generate new methods. We need names for those new methods. The names will be dependent on the attributes that you've declared, right? So here we are creating a new method name called title with sanitization and title without sanitization. You do a define method for the sanitized method. You use the original method, and which we have called, let's say, unsanitized method here as a variable. And you just gsub out all the profane words, right? This could get complex. You could have a profanity list and stuff like that. And then you use alias method. You say that this method name, title without sanitization, is the same as the original method definition, which is title. And then you say alias method that now title, the method name title, will actually be your sanitized version, right? These two lines are actually simplified in Rails. They expose something called alias method chain, which you may have used in your Rails projects. More examples of single line declaration. So here we see a usage of something similar in a controller where we give more options. We say filter profanity for the create action, but only for these parameters which come into that action. We also have something authentication related, has user specific actions, create and destroy. It'll check that the user is logged in, it'll check that the user is allowed to create a post or destroy a post. For comments, we are dealing with is flaggable. We just say it's flaggable, which means people can say report abuse or something like that. And this is interesting. We were also dealing with an activity feed, a wall, like a friend wall on Facebook. And you say whenever a comment is created, right? Let's read this out. Generates, so read it like this. Comment generates feed item, content feed item for addition of comment after create. And I don't have to explain anything further than that. Again, dealing with some background workers. Here we say, and these are AWS SQS based. SQS is the message queue implementation provided by AWS. We just say image worker reads queue to perform rescaling, resizing of images. And the queue name is image, and there is also an error queue called image error, right? And those are only the pieces of code that you actually need in these classes to deal with at least these behaviors. Block declaration, a little more complex. Here we are actually dealing with social networking. Someone mentioned social as a domain. We are saying a fan has a social graph where there are relationships called fan followings, where the fan participates in the relationship as a fan towards a celebrity, and the relationship is outgoing, as in a fan initiates the relationship to a celebrity. On the celebrity end, we have something similar. We say relationship fan followings as celebrity towards a fan, but the relationship is incoming, right? And then we suddenly get methods like these. Madhuri can have a fan named Hussein. Hussein's celebrity list will now have Madhuri in it, and Madhuri's fan list will have Hussein in it. How do we implement this? this we've already seen. There's a class method, but a block can get complex. So you want another object to handle that complexity. That object is specification. Specification is very similar to the builder pattern we saw. It collects your relationship declarations. In the sample, we just had one relationship. You could have a fan community where fans are connected to fans. So you collect all those rules, and then you finally do something with it. So you say apply those relationships on the class which used it. And that's where a lot of metaprogramming happens. This is the relationship class which introduces those methods like add fan, add celebrity, celebrity list, fan list. Again, these details you can look at from the GitHub project, but I'll move on. Some more examples, a little more complex in a real world project. And this is an interesting one where this class level method is actually delegating to this another class level method and then doing something on top of it. So you can have those kind of DSLs as well. And it's something very simple, just another simple one, nothing complex there. So quick recap. Fluent interface is the simplest of all. You can just start there. Single line declarations, you understand modules, mixins, class level methods, basic metaprogramming, easy enough. Block declaration, very simple, similar to single line declarations, except that you may end up doing some advanced metaprogramming there, like instance eval and stuff. You win some, you lose some. So some things to be careful about. Don't go overboard with the builder pattern. Not everything needs it. Keep the builder class responsibility separate from the class you're building. And again, treat default values with care, because you can't expect your consumer to always use those methods. Metaprogramming, don't shy away. I see a lot of hesitation in programmers from metaprogramming. Don't shy away, just be vigilant. Structure your metaprogramming code clearly. Focus on readability, because metaprogramming related code can be difficult to understand. Control your options explosion. We saw that our single line declaration took multiple options. You may get into a habit of adding more and more as your project evolves. Just be careful of that. Use tests and use metaprogramming as a way to remove duplication. But duplication, not the way we typically understand it, but duplication even in the code structure. So keep a watch out for duplication code structure, which you can remove using metaprogramming. Pains in general, debugging can be difficult. Yes, it can be difficult. Unit tests help, but not always. Writing DSL implementation can become easier with practice. Reading it is still difficult. Dealing with variations, we talked about, I think Chad mentioned abstractions can be dangerous sometimes. And here we are talking about abstractions. And as soon as you have variations, you need to control it. And you may think you're making the most elegant DSL beautiful that you understand, everyone else should understand. The biggest risk is when it's only you who understand that DSL. It's not really capturing what you need to capture. There's still benefits though. Productivity, I mean, these are examples that we've seen. Full cycle of use stories. So quick analysis with the QA and developers of what needs to be done, implementation, and then testing, all happens in half a day. Why? Because you have a lot of reusable code. In the examples we saw, has user-specific actions. You can just implement it so many controllers in one shot. Maintenance gets improved because of improved readability and consistency. There is just one way of implementing something. You don't have too much inheritance going on, too much module mixing going on. There's a consistent way of implementing a business concept, which leads to lesser defects and quick fixes. Your Ruby know-how increases in your team members because you're kind of forced to look into metaprogramming a little bit more and some of the patterns which help. Your understanding of the business domain increases a lot because you are modeling business domain in your DSL. And quick ramp up for team members. A team member could join, and we've seen this. And from the second day onward, they're just using the existing DSLs. They don't even need to go and look into it, what's happening under the hood, all that metaprogramming, because the DSL is so clear. And final words, custom DSLs for business domains, just try it. You may fail. Team members may not like it. You can always undo it. But give it a shot, because you are using it every day if you're using Rails, Sunspot, a lot of libraries out there. I mean, just RSpec, right? You are using it every day. Just give it a shot for your business domains. And I'm done. So thanks.